Welcome everyone. In this video I will try to assemble a DIY handheld oscilloscope. So as you can see, we have several parts scattered around the table. This oscilloscope comes with a nice manual. I can show you. And it has all the instructions, and then also it tells you what and how to solder step by step. You even have a checklist for each part, and also it tells you what kind of tools you will need. So I will go through them quickly and check if I have those. So soldering iron is the first one, and then solder wire as well, and it also requires digital multimeter. I have two to make my work simple, and then screwdriver, we have it here, some cutter, so I will have this plier, some tweezers, we have that one as well, 9-volt DC power supply. I can use the same power supply as I will use for my soldering iron, but I have two other power supplies, so that's not a problem. And then another pliers are necessary, needle nose, but I have this flat tipped plier. I think this will do the job, and some small slotted screwdriver. I have a wall set of heads for this guy here, so I think it will not be the problem. And as you can see, so it comes with two instructions. It's just all the steps. This is the casing, and then here are the parts scattered, like different switches, rotary encoder, BNC connector, some jumpers, a board, and then a switch, a knob for the encoder, some capacitor, electrolyte, and ceramic capacitor, and finally some resistors and some screws and some other small stuff. So I will arrange them in order to make my work more simple. It comes with a small scope cable with clips, so we will use it with this one. And of course we have this package here which contains the main board. So basically there are two boards, one board with the screen and another board which will contain some other stuff. So we will go through the manual and solder everything step by step. So first of all I clean up on the table, and I will continue from there. So the table is clean, more or less, and the first part of the instruction is that we should check the board without assembling anything, and it says that we have to connect 9-volt power supply, and we should check the display, and there should be some waves on it. So let's just do that. So this is one part of the board. They say that there is a type which does not come with the pre-soldered SMD chips. Luckily this comes with it, so I don't have to struggle with that. So I only have to get the other like hole mounted parts. But we don't need this right now. So here is the screen. We can like move it a little bit. And this is the other side of the board. So this looks fine. Now I just connect the power supply. And we see what happens. It booted up and it shows the waves which we need. So it matches this stuff here. So we are satisfied and we can start the work. As the soldering generates a lot of harmful fumes, I will make some noise by using my fan, and maybe I will block some part of the picture. So sorry for that. I will do several steps after each other. So I solder this test signal terminal and then the power connector, which is optional, so maybe I will not use it, but I solder it just to practice. And then we will need a slide switch, this one here, and some header and some other switches like this guy here. And I have to remove a resistor. So I complete the whole rest of the step 1, and then I will talk again. So now I have soldered the parts of the step 1, all of it. I had some problems with these jumpers, but I fixed it. One note for soldering: if you solder, it's not enough to just melt this solder wire, but you should also keep it there, because the solder wire and the leg and the hole should be at the same temperature, because otherwise the solder wire will not stick to the surface of the two metals that you are trying to connect. So therefore it's a good idea to try to touch the leg and the hole. They are usually have this metal I don't know what is this layer. So it's good to touch them with the tip of the soldering iron, and then put a little bit of tin or soldering wire on the tip of the solder, and then it will melt it, and eventually the molten metal will flow and cover all the gaps because of the capillary effects. So you should heat it up and not just melt it, because it will be very ugly and it will not provide good contact, but you should also leave the tip there a little bit, and you will see that the molten metal gets sucked in the small gaps and small holes. So yeah, this is just a side note. So now this stuff, oh, I forgot the switch, so I can show you more soldering then. we are supposed to be done with the soldering. So terminal is there, power connector is here, switch connected, pin header connected, switches, all the 4 is soldered, and I have removed this small guy, the R30 resistor. So I just put this aside. And now we have to power again. Now it's in off. And now it's on. So now we are supposed to be able to test the switches. Oh yeah, this one works. This one also. And this is also working. And this is also working. So yeah, we are done. So the next task is a bit more complicated. I have to measure the resistors and I have to solder them. So we go more or less randomly. So I will check these guys. I measure them with one of the multimeters. And then I'm gonna solder them as they come. So I will not pick the same order. So let's start. Well, first of all, I just connect the resistors to the board, and then I solder everything at the same time. So this was a 1 kilo ohm and it was the R5. So I usually just put in the resistor and then I fold the legs like this, so outside, so it will be stiff enough, it will touch the board, so I can just straight away solder it. So now let's see the next. So I was not able to measure one resistor here, which is the R2, 5 mega ohms. So I will take the other multimeter and try with that one, just to be sure, but I excluded all the others, so this is just for fun. Yeah, 5.2. So either this other multimeter has a low battery or just a piece of crap. So now it looks messy, so I will solder everything and then we will see what happens. So the resistors are connected, and now I will move on with the ceramic capacitors. Then I just have 4 pieces, and each of them has their codes, so it will be quite easy to distinguish them and identify them. So, and then at the same time I will also solder the switch as well, because that's the next. So maybe I attach it now to here, to this part. And then we have 2 capacitors with different values, but it's difficult to distinguish them. So one has a simple number on it, or a single number on it, 1, and this has 104. So the 1 is the 1 picofarad capacitor, and then the 104 is the 0.1 microfarad. So it's just good to know. So we solder again. So I just fixed some solders or solderings which were not so nice, and then we can complete 3 more steps at the same time. So we need this 2 times 5 or 2 by 5 pin header. We have 3 electrolytic capacitors, and then we have the BNC connector. So I just solder them at the same time, and we see what is on the next paper right here. So this board is finished, and it's more or less okay. The solders are not the best, but we will see. So we finished with this page, and then we have to go to the next, this one. So now we have to first solder the rotary encoder. It's quite obvious because one side has 3 legs and the other side has only 2 legs. So we just plug in. One leg is a bit like retracted, so let me fix that. So this is all. So I just straight away solder it. It should be easy. However, I have this problem here. So all the legs in, and then I need my guide just to help. So now the soldering part is done. We have to assemble the front module. So we need one plastic part, which is the front part, and we have to fold the stuff inside. And now I don't remove the screen protector, so I just fold this up so it should go through the hole, and then this is it. So this is in, and then we have to move with this, so we fold it over. There are two holes here, so they just slide in nicely. And now we come with the rotary encoder, and we have the 4 pins here, so they should slide on this. And I was wrong, because we have to solder more, but first we have to mount this permanently by using 2 screws here. It requires 2 whatever screws. It says KA2, but I don't know which one is that. So it doesn't say, it doesn't tell. So we guess, because there are some different screws. So we need to solder quickly again. So this was an easy job. Just 4 pins there, which are connecting the encoder to the main board. And I just cut these guys here. So this is done. And now we have to verify the voltages. So if you see, there is a female jack plug here. So that goes together with this male jack, which we recently soldered. And this connector will actually make you stop, so you will feel when you can stop with pushing. So we have everything assembled. We need a multimeter, and then we just check the voltages. I want to show you the numbers, so let's connect the 9 volt power supply here, and then we will proceed with the other things. So 9 volt is in. So it says that we have to connect the ground on this at this corner, and then we have to measure different things. So for example, there is a V plus somewhere on this board here. We connect there, and that should be 8 volts, which is not 8 volts in our case. So maybe I should turn it on. So now it's on, and we check the... So this is okay. And then we have the AV plus next to it, to the left. That should be like 5. That's also all right. And then we have a V minus below it, minus 7.5-ish, okay. AV minus, minus 5, it's okay. And then we have V1, V2, V3, 0. Yeah, it's 0 roughly. It's roughly 0 as well. And V3, let me see. That's also like 0. And then we have V4, which should be 1.65. And it's 1.65. So this is done so far. So as we finished with the soldering and testing the different terminals here with the V1, V2 and other stuff, we have to calibrate the instrument. So this is the step 5. We have to do some important things. So previously at step 4, this switch, which is the AC, DC and GND, was at the GND. So now we go to AC, and then we have to connect the power supply, of course, and we also have to connect the BNC plug. So basically we can do like this, and we only connect the red wire. So I just put the black wire there. So red wire goes here. It should be straight because we have to play around with the trimmer capacitors, which are here in 2 slots. I hope you can see it. So these green guys here on the 2 sides, and then we don't have too much space available. So this is it. Now we have the 9-volt power supply, and we power it up. So first of all, just to make sure that we have output, you can already see some signals jumping around, but I just want to measure the frequency. So basically we just search for the ground, which can be the body of the connector, and then we put it here. And I hope you can see it, but this is exactly 1 kilohertz. So with the calibration signal, we are looking for 1 kilohertz. So this is, I just wanted to show you this. And as the part of the body says, so this is a 1 kilohertz square wave output. This is part of the casing. So we have to connect the, we have to follow the instructions. So yeah, we already connected the red clip here, and then the second one says power up. That's done. And now we have to push the knob down for 3 seconds. Once more. So this blue menu comes up, and we need the 0.1 setting, and now you can see that we already have a square signal, but it's a bit skewed. So we have to set the sensitivity to 50 millivolts. This is right here in the corner, and it is at 50 millivolts. But if you want to do that, you just do with this button, and then you just play around with the knob here. So now it's 50 millivolts, and maybe I can increase. It's too ugly, but we have like this, and we have to make a perfect square signal, and we can have that by turning the C3 trimmer. But first I want to expand this, so I want to change the division a little bit, like this. So you can see it's not too perfect. There is a small deviation on the signal, so the rising edge. So I try to do that now, or try to fix that. So now I put too much, I turned the trimmer too much, because now the edge is going up too much. So I have to turn backwards. and now it seems more or less fine for general purposes. And now we have to turn the other trimmer as well. So we have to change the test signal, because now it's 0.1 volts. So 3 seconds again. We need this blue screen here, and now it's 3.3. So we have to change the volt per division just to be able to see the signal at all. So there we go. We see the signal, the frequency is the same, so we don't change the time division as well, of course. So what we do now is turn the other potentiometer, the C5, which is the closest to the BNC connector. So now it's again, the rising edge of the signal is a bit skewed or tilted in this direction, so I have to correct that, and now I also have to do the same. It is still a little bit unstable. Well, it's not that bad, so I think we can say that we are satisfied with it, because it's more or less flat on the tops and the bottoms, and the edges are quite straight or like vertical. So according to this, we are done with the calibration. So now I have to assemble it. So first of all, I turn off the power. I remove the cables. And now we have to see what the instructions tell us. So we remove this guy here carefully, and then we put it in the other part of the box, which is here. So we have to see so it goes like this. So it's in. Of course, it's moving up and down, but we have 4 small screws right here, and we just use those, and it says that we need to fix it with the 4 screws. So this is done. So the second part says that we have to slide these things together while putting this testing terminal through this hole here. And we also have to make sure that this thing meets these pins here. It's a bit complicated, but we can do that. So this goes in. Now we need this. This is the bottom part, which goes here. So it will cover the connector for the power supply and the on-off switch. And we have the front frame now, so it will just slide on it. So we are done. It's a bit funny feeling, but let's see if it still works. Power supply, we switch it on, booting up. And let's test it with its own signal. It still works, so I think we have succeeded with this. So the next thing that I would like to try is that I can operate this multimeter as a signal generator. So I will try to generate some random signal just to test this guy. So now it can generate a 50 Hertz square signal. I hope it's not too high voltage, but I believe it should be quite low. There we go. So the signal level is quite okay. It's like 3 divisions, which means like 3 volts. But we cannot see the volt signal. So I will try to do that, to fix that. It seems like our signal is like climbing somewhere. Now we have it. It seems like that the signal is a bit skewed. So either something changed with the capacitors that we have just calibrated, or something is wrong with this signal, but at this moment we will skip it. Now I change it to some random value. So 100 Hertz, 200, so I should change the division. Now the signal looks nice. 300, 400, 500. Even right now it looks very good. So yeah, I think that's all. So I think together with making this video and assembling everything, it took me like 1.5 hours to follow the instructions and assemble this small digital oscilloscope, which I think it's not too long time. Especially this was my first time to see these instructions, so I haven't really checked the instructions before starting with this video. So I would say that the instructions, the manual, are very nice. It's very clear, it's easy to follow, and all the drawings and the values which are shown and everything makes sense. So this is very good. It's very good that they include like a sort of troubleshooting. So you should check the state or the condition before starting with the process, and then you have here in the step 4 some other checkup process. You can also calibrate your oscilloscope, so you can make the best out of it. And then it's quite simple to use it. Also the drawings on the circuit boards itself, so I mean you can see it here, so they also very clear, so it's relatively easy to find the places of each component. And yeah, this oscilloscope is very nice. It's easy to handle it, easy to do basically anything with it. The cable, well, it's fine for the basic purposes, but if you want to like make your oscilloscope more smart, then you should buy a cable with a probe, and then that's maybe more easy to use when you have circuits with like very crowded areas, so you can easily just punch in that pin and easily measure the signals in the circuit board. And I think that's all. You have all the instructions here, so you can see some extra options. So I did not go through everything, so it can do more that I showed here, definitely more. And there is a small troubleshooting, so if something does not work, you should just go for this. And they also have some website where I believe that you can get all the support and stuff like that. So I think that's all. So it's a nice oscilloscope, and you can bring it anywhere, and you can measure whatever you want anytime. So I hope that this walkthrough, or whatever it is called, was useful for you. I hope I could help. And if it was helpful, then just try and assemble this thing, because it's a funny and very useful instrument. And if you want to buy it now, it's very cheap, like $16 US, so not a big price. Then you can find a link in the description and you can buy it if you want, but you don't have to use it. And yeah, so I hope you enjoyed the video and have fun with this tool. So see you in the next video.